Okay, now we move into a few application problems. This first problem, however, is just a literal equation in which they ask us to solve for t. Notice that t is trapped up in the exponent position. So first thing we want to do is isolate this exponential term, and that means dividing by this n sub 0 on each side. This is going to give us, on the left side, n over n sub 0 is equal to e to the negative 0.025t. Because there's an e in the problem, it is going to be easiest to take the natural log of each side. That gives us the natural log of n over n sub 0 equals, the power comes down, negative 0.025t times the natural log of e. Now that natural log of e has an understood base of e, and natural log of e base e is equal to 1. E to the first makes e. So we can pretty much just cross that part out and just have the right side of the equation without that. And we can now solve for t by dividing by that decimal. We will have the natural log of n over n sub 0 divided by negative 0.025. And that would be the solution. Okay, in this next problem we're asked to do the same thing, but this time capital I is trapped inside of a logarithm. So we're going to begin by dividing each side by 10. That will give us L divided by 10 is equal to the log of I over IO, I sub 0. To undo this log, actually, let's do it this way. Let's take the base of 10 that's there and go 10 raised to the other side equals the argument. We now have 10 raised to the L tenths power is equal to I over I sub 0. Now we're solving for I, and so if we just multiply to get rid of that fraction, we're pretty much good. I is equal to I sub 0 times 10 to the L over 10 power. And that becomes our solution to this literal equation. Now we have an investment problem. Suppose that $50,000 from an investment account is invested in a large cap stocks fund. After 20 years, this becomes the value. Now they want us to use this formula, the PERT formula, to determine the average rate of return when there is continuous compounding. Even if they hadn't given us this formula here, the word continuously compounding would have told us to use this formula. So substituting in, our value of A is 194,809.67, and that will equal 50,000 for the investment times e to the r, which is unknown, times t, which is 20 years. So I'm going to write that as 20r. The next thing we wish to do is divide off the 50,000 on each side. This will just give us the exponential term on the right. Dividing on the left, we get 3.8961934. Now it's important that we either keep that number in our calculator's memory or that we write out quite a few digits to be able to get the accuracy. This will equal e to the 20r. Now since our r is trapped up in the exponent position, we want to log both sides, and since there's an e right here, taking the natural log of each side is the most convenient way to do this. So we will have the natural log of this 3.896 number is equal to the 20r, which comes down, times the natural log of e. Well, the natural log of e has a base of e, and e to the first makes e, so that expression there is equal to just 1 on its own. So now we want to isolate the r by itself, which means we need to divide 20 off of each side. So we will have the natural log of 3.8961934 divided by 20 is equal to r. And when you do this on your calculator, you will find out that r is approximately 0.068, and so our interest rate that we're going to be looking at would be 6.8% to make this amount of money over those 20 years. Now the question is, using these same conditions, how long will it take the investment to reach $250,000? Well, that would be $250,000 in the account when $50,000 is invested. E raised to the 0.068, we just found that in the problem above, times t, we're solving for how long it will take for that to happen. When you divide off that 50,000, the left side is a nice clean 5 equals e to the 0.068t. We will then take the natural log of each side. So the natural log of 5 will equal 0.068t natural log of e, which we've already said is equal to 1. And so then t, after dividing each side by that decimal, is the natural log of 5 divided by 0.068. And I probably should put my leading 0 there since that's our exact answer. Now, what is that when we use our calculator? Well, that is 23.668. And so they said round to 1 decimal place, so I'm going to go with 23.7 years for that $50,000 to grow to $250,000.